Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions.
This particular paper is AQA June 2024, paper 3, FoundationTier.
Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends because they might need a helping hand too. Okay, let's get into it.
Question 1. Work out 10% of 170. Well, 10% is 10 100ths, or a tenth of the number, so to find it we just need to divide through by 10, don't we? So what is 170 divided by 10? It's 17, isn't it? Question 2. Write down the value of the digit 7 in 34,728. Well, if you just read it out loud, I said 700, didn't you? So the value of that digit 7 is 700. Question 3. Write down the name of a triangle with 3 equal sides. Well, the triangle with 3 equal sides is an equilateral triangle, isn't it? Equilateral triangle. There we go. Write down the name of the straight line inside this circle. Well, you just need to straight up know your parts of circles for this paper. That, ladies and gentlemen, is a chord. It's a line joining 2 points on the circumference of your circle, so it's called a chord. Question 4. Write down all the factors of 45. So I tend to do these in a little tree. So I put 45 at the top, and then I start with 1. Does 1 go into 45? Yes, it does. Does 2 go into 45? No, because it's odd. Does 3 go into 45? I think it does. 3 into 45 goes 15 times. Does 4 go into 35? Nope. 5. Yep, ends in 5, so we've got to go 5 then, isn't it? So 5 and 9. Does 6 go into 45? No, it doesn't. 7? Nope. 8? Nope. And then we've met ourselves coming back down the other end, haven't we? Because we've got tested all the numbers between 5 and 9. Okay, so the answer is going to be 1, 3, 5, 9, 15, and 45. Question 5, part A. D equals g squared minus 2h. Work out the value of d when g is 15 and h is 63. So we've got to do a substitution here, don't we? So if g is 15, then I need to replace 15 there, where the g is. And if h is 63, then similarly I'm going to have to replace that one there with 63. So then d is going to be g, but g is 15. So 15 squared minus 2 lots of h, where h is 63. Okay? Just going to do this on my calculator. So 15 squared minus 2 times 63. What does that come to? Apparently that's 99. So that's my answer for D, 99. Okay. Part B says rearrange m equals n plus k to make n the subject. So I want this to be about n is equal to, and at the moment I'm adding k to it. So I want to do the opposite of adding k to both sides. So if I take away k from both sides, on this side it's going to cancel, leaving me just n. So that's going to give me m minus k on the left and n on the right. So that's my answer then, isn't it? So n is m minus k. Just spinning it around, writing the n at the front rather than at the back. Question 6 here is a right angled triangle on a centimetre grid. write down the coordinates of the midpoint of the longest side. Okay, so the longest side is this one down here, look. And I guess, I mean, we could do this by eye. I think by eye it's probably that point there, but I think we're going to just check by doing it properly. So to find the midpoint of a line, what you need to do is average out its coordinates. So if you think about the top coordinate, that is 1, 5, and the bottom coordinate is 9, 1. So then if I want to average out the coordinates, I'm going to take the x coordinates, add them together and divide by 2. So 1 and 9. What's the average of 1 and 9? So if I take 1 plus 9 and divide it by 2, then my x coordinate is going to be 10 divided by 2. It's going to be 5. And my y coordinates are 5, 5 and 1. And so averaging those out the same way, 5 plus 1 over 2. 5 plus 1 is 6, divided by 2 is 3. So my coordinates are going to be 5, 3. Now actually, I did manage to pick that coordinate out there, didn't I? 5, 3 by sight. But yeah, sometimes it's not so easy to see. So yeah, doing it the proper way by averaging out your coordinates is probably the way to go. And then 6b says work out the area of a triangle. Well, area of a triangle is equal to half base height, isn't it? So you multiply the two sides together and you halve it, and that's going to give you your area. So what is the base? The base is the side along the bottom there. It's that side there. Now how long is that? Just count in squares. That's 1, 2, 3, 4, 5, 6, 7, 8 in that direction. So that's 8 units. So that's going to be 8. And then my h, the height, that's that distance there. Look, that's going to be my height. How high is this thing? Well, again, counting squares, that's 1, 2, 3, 4 going up then. So then the area of my shape is going to be a half times the 8 times the 4 then, isn't it? So half 8 is 4, 4 fours are 16, so it's going to have an area of 16 centimetres squared. Question 7. The total cost of broadband for 5 months is £99.20. At the same monthly rate, work out the total cost of broadband for 2 years. Okay, well, this is a monthly rate, and so how many months is it going to be over 2 years? So over 2 years, that's 2 lots of 12 months, isn't it? So number of months equals 2 times 12, which is 24 months. Okay, so I've got 24 months altogether, and so it's a bit weird because this is a 5 monthly rate, isn't it? I suppose we could work out the month for 1 month. Cost per month would be the £99.20 it costs for 5 months divided by 5, assuming that they'll let you pay the last, you know, they'll pay only 4 months rather than 5. So 99.2 divided by 5, that comes to £19.84 per month. It's a lot cheaper than what I'm paying for broadband, I can tell you that. £19.84. Okay, so cost per month is £19.84. So 24 months at £19.84 a month. So total cost is going to be the 24 months that we're buying broadband for at £19.84 a month. Okay, so timesing that by 24, that comes to £476.16. Question 8, here's a cuboid. Work out the volume of the cuboid, give your answer to 1 decimal place. Okay, so the formula for working out a cuboid is volume equals length times width times height. So here the length is there, look, that's the length. It's going to be 6.75. The width is that one there. That's the width of my shape. That's 2.7 centimeters. And then finally my height, that's going to be that dimension there, which is 3.8. So subbing those into the formula, that's going to be 6.75 times 2.7 times 3.8. Okay, this is a job for my calculator, I think. 6.75 times 2.7 times 3.8. Now I make that 69.255. Now I want the answer to 1 decimal place, so I need to round that off. Okay, so my 69.255, I'm going to round off after 2. The next digit is a 5, so I need to round up. So that's going to be 69.3 then, isn't it? So 69.3 is my solution. Question 9. Nikki asked 30 people to name their favourite crisp flavour. Here are the results. Salt and vinegar, 16. Ready salted, which is the superior flavour, is 7. Cheese and onion is 5. And prawn cocktail is 2. Nikki drew the pictogram to represent the results. So she's got some symbols there for 16, and some symbols for 7, and some symbols for 5, and some symbols for 2. Okay. So, what 2 mistakes has Nikki made? Now, first off, I get what Nikki meant. This salt and vinegar here is meant to be 16, and she's done kind of 4 big crisp shapes, and then divided them into 4 pieces. So, I guess what she meant, or he meant, I don't know what Nick is that they're meant to be big crisps divided into 4. So you've got 4, 8, 12, 16 there. But I'm only guessing because there's no key. There should be a key saying what that crisp symbol means. So I'm going to write that down as my mistake 1, that there is no key. And I'm just going to draw what I think the key should look like. E.g., this symbol equals 4 people. Okay, so then I know how to read that scale better then, don't I? It's quite clear. I don't have to guess what each of these symbols mean. I know up front because it's telling me. Okay, and then the second mistake, I think, well, if I just count those number of shapes there, what they've drawn, so that represents 16 because you've got 4, 8, 12, 16. I've got 4 and 3 there making 7. I've got 5 parts there, and I've got 4 parts here, but that doesn't match. So this 2 here for prawn cocktail is different from the symbol for there, isn't it? Okay, so they should have done like a half crisp there. So I'm going to write the prawn cocktail should have half a circle. So something that looks like that then, not a whole one. Yeah? Question 10. Sanjit buys 1.75 kg of potatoes and 4 kg of leeks. The total cost is £9.03. The potatoes cost 84 pence per kilogram. Work out the cost per kilogram of the leeks. Okay, so we know that the potatoes cost 84p a kilogram. So potatoes are 84p per kilogram, and we know that she bought 1.75 kilograms of potatoes. Okay, so we can use that fact to work out how much she spent on potatoes. Well, then we can deduct that from the total. We'll know how much she spent on the leeks. Okay, so for the potatoes, now I like to do little subheadings as I go through, so it's clear when the examiner's marking it what I'm doing. So the cost of the potatoes was going to be the 1.75 kilograms of potatoes times the 84 pence that they cost. Okay, I've just switched into pounds there because the total is in pounds. So what's 1.75 times 0.84? That comes out to be £1.47. Okay, so we'll just spend £1.47 on potatoes. Okay, so then switch into leeks now. How much did we spend on leeks? Well, we know we so cost of leeks, that's going to be the total cost up here, look, total cost minus the cost we spent on potatoes. So it's going to be £9.03, the total cost, minus the cost of the potatoes, which is £1.47. Okay, so that's where those two numbers came from. So what's that then? £9.03 minus £1.47. Just going to do that on a calculator. 903 minus 1.47. That comes to a £7.56. £7.56. We also know that there were 4 kgs of leeks, so we know that 4 kilograms of leeks cost £7.56. So the cost of 1 kg leeks, what's that going to be then? It's going to be the £7.56 that they cost divided by the 4 kg that we bought. So I just need to divide my last answer by 4, and that's giving me £1.89. So £1.89. So then the leeks cost £1.89 per kilogram. Question 11a. Simplify fully 2x plus 9y plus 1 plus 8x minus 5y minus 7. Now we've actually got 3 different types of thing here. We've got terms in x, of which we've got a 2x there and we've got an 8x there. We've got terms in y, and I've got a 9y there and a minus 5y there. And we've got numbers or constants, so I've got a 1 there and a minus 7 there. Okay, so when we simplify, we're going to be collecting these like terms together. So like with like, so we're going to add the 2x and the 8x together. So 2x plus 8x is 10x. So collecting those together is going to give me 10x. Next, we need to collect the y's together. So 9y take away 5y. Now notice that I've kind of highlighted the sign in front of the term as well as the term, because the sign kind of belongs to the term that follows it. So that reads positive 9y subtract 5y. So 9y take away 5y is 4y. So plus 4y. Okay, so that's my green terms. And then I've got plus 1 minus 7. So if you're at 1 on the number line, you subtract 7. It's going to take you down to minus 6. Okay, so that's my solution. 10x plus 4y minus 6. And then part B says circle the expression that is equivalent to 0.5a squared. So 0.5 is a half. So what we've got there is a half of a squared. And then if I times those things together, then that's going to be a squared over 2 then, isn't it? So it's actually that one there. Question 12. Here are the subjects available in year 12 at a school. So in block 1 you've got maths, history and French, block 2 is geography, drama and chemistry, block 3 is English, physics, ICT, and block 4 is Spanish, biology, art. Students choose 3 subjects. They cannot choose more than 1 subject from a block. Liam decides to study maths, not to study geography, chemistry, physics or ICT. By listing, show that there are 7 groups of 3 subjects that Liam could choose. Okay, or Leon. Okay, so has to choose maths. Now, there's only one place to pick maths, and that is in block 1. So I have to pick block 1. So maths is going to be block 1. Maths. Definitely going to be maths. And then, what else have I got? Not study geography, chemistry, physics or ICT. So let's put a cross through those. So not geography. Where's geography? There. Gone. Where is chemistry? No to chemistry. Physics. No physics. And no ICT. Okay. So now from block 2 you can only pick drama. So I'm going to write down maths drama as one possible solution so far. And then he's got a free choice from either block 3 or block 4 for subject 3. So he could pick English. Oh, we can just do initials, can't we, rather than writing all the words out. That's going to take forever. So I'm just going to write M and D. So maths, drama, English is one combination. Or we could do maths, drama, and any one of the block 4 choices. So I could have Spanish, could have maths, drama, biology, maths, drama, and art. Okay, so they're all possibilities. Or I could not do subject 2, or I could not do block 2 at all, not pick drama, and I could pick block 3 English instead as my second subject. And then again, I've got those 3 choices for block 4 to finish off. So I could have maths, English, Spanish. I could have maths, English, biology, or I could have maths, English, art. Okay, so they're all my 7 choices then that it's possible to get from that arrangement. Question 13. There are 1,400 students at a college. A student is chosen at random. The probability that the student is taking a GCSE resit is 0.09. How many of the students are taking a GCSE resit? Okay, so the probability that they're taking the reset is 0.09. So that is the relative frequency, isn't it, or the probability. So the number of expected outcomes is equal to the probability times the number of trials. So to work out the number of students taking it, I'm going to multiply the 0.09, which is the probability of any one student having to do a resit, and then I'm going to multiply that by the number of students, which is 1,400. And what does that come out to be then? So calculator, what is 0.09 times 1400? Apparently it is 126. Okay, and that's my answer. So 126 students will be taking a GCSE reset. Then part B says the probability that a student is studying A-level maths. Part B says the probability that a student is studying A-levels is 0.67, and the probability that they're doing core maths is 0.48. Show that some students are studying A-levels and core maths. Well, the thing is, if you add those 2 scores together, 0.67 plus 0.48, what do you notice? Well, if I just add it together quickly, 0.67 plus 0.48, that comes out to be 1.15. Okay, so that tells me instantly there must be a crossover here. Some of the students must be doing both, because all the probabilities should add up to 1 and not 1.15 or more. Okay, so I'm going to say probabilities of outcomes should add up to 1, as 0.67 plus 0.48 equals 1.15, which is greater than or equal to 1. It shows some students must be doing both. Question 14. Des delivers takeaways to houses A, B and C, and we've got a map here, not drawn to scale, well, not drawn accurately, it says. That's weird. So it's got a scale of 1 centimetre represents 3 miles, but then it says not drawn accurately. I don't really know what's going on there. Right, so let's have a look. So Des, because it's measured. So it's measured and the amounts are on there. So the actual lines might not necessarily match, but we should be using the numbers, I guess. So Des drives from T to A and back, and from T to B, and then B to C, and then C to T. Right, so Des drives from T to A. So he's going from T to A. Where's T? So he's going from here. He's going from here, and then back again. So that's 0.6 plus 0.6 for that part, and then he goes from T to B. So presumably he then goes up to there, which is 1.3. From B to C, so then he's going from there to there, which is 0.8. And then from C to T, so he's coming back round here, which we're told is 1.7. Okay, I haven't really bothered following the lines, but you get the idea. Okay, so how much is that all together then? In centimetres, adding all that up then, that's going to be 0.6 plus 0.6 plus 1.3 plus 0.8 plus 1.7. That comes to 5. So altogether, he's travelled 5 centimetres on the equal map. And we know that 1 centimetre represents 3 miles. So that's equal to 5 times 3 is equal to 15 miles he's travelled altogether. So he's gone 15 miles. We know that Des is paid 40p for each mile he drives and £1.35 for each house he delivers to. Okay, so it looks like he's delivered to you 3 houses, because he went to A and he came back again, and then he went to B, and then he went on to C, and then he returned back home again to the takeaway. So it looks like he's visited 3 places. Oh yeah, it tells you up here that he did 3. His pay is going to be the £1.35 he gets per delivery times the 3 deliveries. So what's that? £1.35 times 3. Okay, so this is for the deliveries. £1.35 times 3, that comes to £4.05. And then for the miles, he gets, what's that, 40p for each mile. So that's 40 pence times the 5 miles that he drove or cycled. I don't know what he's on. Okay, so 0.4 times 5, that comes to £2. So then the total amount he got was £6.05 then. That's the total. Okay, so all in all, he earned a rather paltry £6.05. Not a lot, is it? Question 15. Here are 2 number machines. So I've got an input of 30, we're dividing it by 6 and we're adding 18 to get the output, and we've got an input of 30, we're timesing it by 3 and we're subtracting A and getting the output. Now we're told that the outputs are the same, work out the value of A. Okay, so the first number machine, everything is complete, so we can just work out what the output is. So if I start with 30 and then I divide it by 6, 30 divided by 6 is 5, isn't it? So out of that first box I'm going to get 5. And then if I add 18 to 5, that gives me 23 altogether. So the output from the first function mean is 23. So if the function for the second one is the same, it must also be 23. Now, normally I'd work backwards here to work out A, but I actually think it might be easy to kind of come at it from both ways. So 30 times 3 would be 90, so my kind of midway value here would be 90. And then if I subtract A, I get 23, isn't it? So I can write that down as a bit of an equation, that 90 take away A is 23. So what is the value of A then? So what would I have to take away from 90 to get 23? A must be equal to what? 90 take away 23 would be 70, 67. So 90 take away 67 is 23, isn't it? So A must be 67. Question 16. Which is closer in value to 2.5? Is it 3/4 or is it 4 1/5? They're not, either of them are not particularly near. I think what we're going to do here is we're going to try and express them all as fractions over the same denominator. So 2.5, that's 5 divided by 2, isn't it, as a fraction? It's 5 halves, or 2 1/2. I guess you could write it as 2.5 is 2 1/2, which multiply those two together, get 4, add the 1 on the top. I'm going to get that is equal to 5 halves. Okay, so that's the target. We want to get closest to 5 halves. 3/4 is 3/4. Now 4 and 1/5, if I convert that into a top heavy fraction, 4 times 5 is 20, plus 1 is 21. So that's 21 over 5. Okay, so I'm going to have 5 over 2 in the middle, and then 21 over 5 on one side, and I'm going to have 3/4 on the other. Now which one is nearest? Well, to work that out, I'm going to find a common denominator here of all 3 fractions, and I'm going to convert them up, and I'm going to see which one is closer. So what number does 4, 2 and 5 all go into? Well, I guess they all go into 20, don't they? So I'm going to change these all to fractions over 20 so I can easily see the gaps. Okay, so 3/4 is how many 20ths? Well, 4 goes into 25 times, so times in top and bottom by 5. I'm going to get 15 over 20. 2 goes into 20 10 times, so times in top and bottom by 10. I'm going to get 50 over 20. and then finally 5 goes into 24 times, so times in top and bottom by 4, that means 21/5 is the same as 84/20. Okay, so now we can work out, because they're all in the same denominator, it's much easier to work out the gaps between these numbers, isn't it? So how far is it from there to there? So how far is the gap between there and there? Well, if I do 50/20 take away 15/20, 50/20 take away 15/20, that's going to tell me the gap. That's 35/20. So the gap between those is 35/20. Now what about the other one? What's the gap between those? What's the gap between 84/20 and 50/20? So I do the subtraction there. I'm going to get 34/20. So the gap here, 34/20, is slightly less than the gap between the other two, isn't it, which is 35/20, and therefore it must mean that the second number, 4 1/5, must be closer to 2.5 than the other one, okay, because that has got the smallest value. So which one is closest? 4 1/5. I might say that this one is the smallest. Okay, just to make it clear why. Question 17. A computer game has 5 levels. Each level has a maximum number of points. These maximum numbers form an arithmetic progression. That's just a linear sequence to you and me. The table shows the numbers of the first 3 levels. So it's 400, 75, 1100. Now, it's a linear sequence or an arithmetic progression. That means the gaps between these numbers must be the same. So the first 3 levels, what's the gap between there and there? So 400 plus 350 would take you from 400 to 7,500. And add in another 350, it's going to take you from there to there. So add in another 350, it's going to take me to what? 1,100 plus 350. That's 1,450, and then level 5 must be 350 on top of that, which is 1,800 then, isn't it? Okay, so that must be the scores for the levels required. So your score is the total of the points you achieve at each of the 5 levels. Isaac's best score is 150 points less than the highest possible score. Work out his best score. Okay, so your score is the total of all the points you achieve in each of the 5 levels, and the maximums there are shown. So if we add all those up, that will be the total number of possible points. So let's just quickly work that out. So what is 400 plus 750 plus 1100 plus 1450 plus 1800? Now that comes to 5,500. Okay, so that's the total amount of points is possible to get. So if Isaac's best score is 1,250 less than the possible high score, then he's going to get 5,500 minus 1250. So this is Isaac's best score. So it's going to be the 5,500 minus the 1,250, so minus 1250. So that comes to 4,250. So that is his best score. Question 18. A working group has 210 members. Question 18. A walking group has 210 members. One week, the group organised a walk on Wednesday and a walk on Saturday. The frequency tree shows how many members went on the walks. So, 210 people went all together, so that's there. So, went on the walk on Wednesday, yes, 78, no, 132. And of those who went on Wednesday, some walked on Saturday, some didn't. And of the ones who didn't walk on Wednesday, some walked on Saturday, some didn't. Show on the information on the Venn diagram. W is the members who went on the Wednesday walk, and S is the members who went on the Saturday walk. Now, some went on both, didn't they? and I'm going to start with those. I'm going to start with the ones who went on both. Who went on both? It was these people here. Yes for Wednesday, followed by yes for Saturday. So they're going to appear in the middle of my Venn diagram in here, aren't they? Because if they went on Wednesday and Saturday, then they go in the middle here. So that is going to have to be 53 people. Okay? So 53 people went on Wednesday and Saturday. Now, some people went on Wednesday only. They are going to be the people who went on Wednesday and didn't go on Saturday. So these people here who went Wednesday but not Saturday, they are going to be the people in this section of the diagram, aren't they? Because they went on Wednesday but they did not go on Saturday. Okay, so how many is that? That's 25 people go in there. Okay. What about the people who did not go on Wednesday but did go on Saturday? So didn't go on Wednesday is the bottom branch. So it's those people there, didn't it? So they were no to Wednesday, yes to Saturday. So they're going to go in this section of the diagram because they did go on Saturday but they didn't go on Wednesday. And that is 68 people. Okay. And then I guess then the rest went to neither then, didn't they? So this last one down here has got to be the people on the outside of the bracket. I could do the whole thing, but I'm just going to shade that a little bit there. So they are the 64 people who were nope for Wednesday and nope for Saturday. Okay. Now you might want to just double check that adds up to 210. I'm pretty sure it does because of the way the frequency tree works. They all kind of branch out of 210, those four values, don't they? So I think it's good. The length of a line is 8 centimeters to the nearest centimeter. Complete the error interval. Okay, so if it's round into 8 centimeters, if you imagine a ruler and you had 8 centimeters marked on it, and it was and the ruler had centimeters, so the boundaries at either side are going to be 7 and 9, aren't they? So which numbers round to 8? It's going to be the numbers that are halfway between 7 and 8 up to halfway between 8 and 9, then, isn't it? It's the numbers in this range round to 8. You know, if it's slightly smaller than this point there, it's going to round down, and if it's slightly bigger than this point, it's going to round up. So halfway between 7 and 8 is 7.5, and halfway between 8 and 9 is 8.5. So the error interval is going to be 7.5 is less than or equal to the length, which is less than 8.5. Okay, so notice the different signs there. You've got greater than or equal to there, or less than or equal to, depends which angle you're looking at it, and then a strictly less than simple second, because it can be equal to the lower bound but it can't be equal to the upper bound. Question 20. Which of these is an estimate? Is it the lowest value of an ungrouped data, the range of ungrouped data, the modal class of grouped data, the mean of grouped data? I don't think it's the lowest value of ungrouped data, because if you've got a group of ungrouped data, like, 5, 2, 7, 9, 6, 1, 6, then, the lowest one is just scan through and you pick out the lowest value in the group, and that's your lowest value, isn't it? So I don't have to estimate anything there. I just go through my list and select it's that one there. Okay. Similarly, with the range of an ungrouped data, I would just take the highest value and the lowest value, take it away from each other. There's nothing there to estimate. That is not an estimate. Now, the modal class of group data, don't have to do any estimating there. If I've got a table with some groups in it, and 5 had those, 7 had those, 6 had those, 2 had those, then the modal group is just the group that occurs the most, so it's going to be like the biggest group. So again, there's nothing to estimate there. The mean of group data, though, we do need to estimate, because if I had like groups that are going from 0 to 5, 6 to 10, 11 to 15 and so on, then I'd have to estimate using the mid values of those. So I'd have to kind of use 2.5 and 7.5 and so on. So because I'd be picking out the midpoints, it is the mean of group data that is definitely an estimate. The rest, no, they're not estimates. Carly's total annual pay equals her salary plus her bonus. Last year her salary was 26,000 and she got a bonus of £4,000. This year, her salary is increasing by 6%, but her bonus is decreasing by 9%. So work out the percentage change in her total annual pay. State whether it is an increase or a decrease. Okay. So there's actually quite a bit to do here. Right, so last year she earned the total of her salary plus a bonus. So last year she got a total of £30,000, didn't she? The 26,000 plus the 4,000. Okay. Now this year, her salary part, the salary component of her wage, is increasing by 6%. So final, original, multiplier. Let's work out what's going on here then. FOM, stick your thumb on it. I like to use this triangle for my percentages. Now the final amount is the amount that's going to happen after the 6% increase has been applied. The original is, well, it's going to be the starting salary, which is going to be the 26,000, isn't it? That's there. That's going to be 26,000. And the multiplier, well, we've got a 6% increase, but what are we increasing? We start with 100% and we're increasing it by 6%. So that's going to give me 106%, which as a multiplier is 1.06. Okay? So for the salary component, final equals, we'll just stick your thumb on the one you want, which is final, and that tells us what to do with the other two. It's original times multiplier. So final equals original times multiplier, which is going to be the 26,000 she earned last year multiplied by 1.06. Okay, time to reach for the calculator. So 26,000 times 1.06. I made that 27,560. Just going to write that up here as well. So it's all in one place. Now we also need to work out what's happening with her bonus. Her bonus is decreasing by 9%. So I'm going to do another triangle. Final, original, multiplier. Now this time, well, I'm still looking for the final after a decrease of 9%. Now last year it was 4,000, so that's going to be my original. The multiplier, so that's the original there, and the multiplier this time is going to be that 9% decrease then, isn't it? So 100%, because you always start with 100%, minus 9%, because it's a decrease, leaves us with 91%, and 91% as a multiplier is 0.91. So again, final is equal to original times multiplier, the original this time being 4,000, the bonus, and the multiplier being 0.91, the amount we're going to get this year. So 4,000 times 0.91, that comes out to be 3,640. 3,640. So that's going to be the bonus component for this year. Okay, so then the total for this year is going to be those two numbers added together. So the 3,640 plus the 27,560 from the salary, that comes out to be 31,200. Okay, so despite the increase on the salary being less than the decrease on the bonus, you know, because the salary was worth more to begin with, it ended up contributing more overall, and her salary has actually gone up by a little bit. Okay, now we're not quite done yet because we need to work out what the percentage change was from last year to this year. So we're going to do another triangle. Final, original, multiplier. This time we know the final and the original. We want the multiplier. The final is the new salary. It's the 31,200. The original is the old salary, 30,000. And the multiplier is the thing we want to find. We want to find the percentage change, don't we? That's the thing we want. So putting our thumb on the thing we want the multiplier. Multiplier is final over original. So multiplier is final divided by original. That's going to be 31,200 divided by 30,000. What's that going to be equal to? 31,200 divided by 30,000. Now that comes out to be 1.04 as a decimal. Now 1.04 as a percentage would be 104%. And that as an increase then means an increase of, well, if you had 100% to start with and you now got 104%, it's an increase of 4%. Okay, and that is our final answer. It's an increase of 4%. The first two cube numbers are 1 and 8. Show that the third cube number can be written as the sum of three different prime numbers. Well, the third cube number is 27, isn't it? Because it's 3 times 3 times 3. So 3 cubed is 27. So that's going to be the third cube number. Now, is that apparently I can write that as the sum of three different prime numbers. So I need to find some prime numbers first, don't I? So I need to find the prime numbers that are less than 27, I guess, so I can combine them to make 27. So what are the primes? We've got 2, we've got 3, we've got 5, we've got 7, we've got 11, we've got 13, we've got 17, 19, not 21, 23, not 25, and 27 not either. So they're the primes that we've got. So we want to add up to 27. Now it's an odd number, so can't include 2 then, can it? Because an even plus an odd is an even. So it can't have 2 in it. So what can we do? Let's say we add 3 and 5, we get 8. We've got 19 left to find. So that works, isn't it? So 3 and 5 and 19 works. There might be others. I don't know. Can I be bothered to find out? Not really. But if you've got another set of numbers from this set of numbers that adds up to 27, go you. You'll get the marks. We'll use trigonometry to work out the size of angle W. All right, nice straightforward trigonometry question. So what do we know about trigonometry? SOHCAHTOA for right angled triangles. So what I normally do is I write down the mnemonic SOHCAHTOA, and then I work out what sides have been given and so which ratio that I need to use. Okay, so label up my triangle. Here's the angle down here. Okay, and there's the angle. This side is the longest, so it's got to be the hypotenuse. The 6.7 joins onto the angle that I've been given, so that's got to be the adjacent. And this one over here that we don't know anything about and don't want, that's the opposite. Okay, so then you need to choose which is the right ratio to use in this case. Now I often find it's easiest to think about the one I don't want rather than the two that I do. So I can see I don't want the opposite because I don't know it and I don't want it. So any of the ratios with an O in it, it can just remove. So it must be the cosine that I'm after. That's kind of how I do it. So rather than finding two things, I just find one and get rid of them. So it's the cosine I want. So I'm going to write down the full cosine formula. Cos theta is equal to the adjacent over the hypotenuse. Now when you remember the trigonometric formulas, remember them with the placeholder for the angle. Don't forget about the theta, because lots of students make errors subbing into these because they just write cos equals rather than cos theta and don't know where to stick their angle. So cos theta is equal to adjacent over hypotenuse. Now in this particular case, we haven't got theta, we've got W standing in for the angle. So I'm going to switch to W, cos W, and I'm going to sub in the other two values as well. So the adjacent is 6.7 there, look. 6.7, and the hypotenuse, that's over here, look, that's 8.3. So 6.7 divided by 8.3. And then I want W. I've got cos W is equal to that fraction, but I want W. So what I'm going to have to do is I'm going to have to use the inverse cosine here, aren't I? To get rid of that cos W and just get W, I need to take the inverse cosine of both sides, and that's going to give me cos to the minus 1 of 6.7 over 8.3. Now I'm going to type that into the calculator. Just make sure your calculator is in degrees mode. It's got a little D on the top of the display, otherwise you'll get the answer wrong. And then I'm going to press the shift key before pressing cos, so I can get cos to the minus 1. And then I'm just going to put it in using the fraction key. So I'm going to put 6.7 on the top, and I'm going to put 8.3 on the bottom, and ask the calculator to give me the answer. I make that 36.17, which I'm going to round off. I'm just going to round off to three significant figures. So that's going to be 36.2. 36.2 what? This is an angle, so it's going to be in degrees. 36.2 degrees. 2 bags contain only green discs and yellow discs. Bag A contains 1 green disc and 4 yellow discs. Bag B contains 3 green discs and 7 yellow discs. 1 disc is picked at random from each bag. Complete the tree diagram with their correct probabilities. So I've got bag A. I like little visual things, so I'm gonna. I've got 1 green disc and 4 yellow discs. 1, 2, 3, 4 in a bag. There's my little bag, and then I've got bag B, and then I've got, what have I got in there? I've got 3 green discs and 7 yellow discs. What thing is going on in that bag? 3, 4, 5, 6, 7. Okay, it's quite a simple, straightforward question, this one, but you know, I think it's a good idea to visualize things. So there we go. There's my 2 bags. So I'm going to pick one is picked at random from each bag. So this is an example of independent probability, because what I pick in bag A cannot in any way influence what I'm going to pick for bag B. You know, if I had to pick something from bag A and then put it in bag B and then pick from bag B, it would be different. But I don't. I'm just picking from bag A and then I'm picking another one from bag B. Now, for bag A, there's 1 green one and 4 yellow ones, meaning that there are 5 discs altogether. So the probability of getting a green is going to be 1 out of 5. Okay. So the probability of not getting a green, in other words, getting a yellow, is going to be 4 out of 5. Okay, so we're done with the bag A. Switching to bag B. Now I've got 3 green, 7 yellow, making 10 altogether. So the probability of picking a green one is the 3 green ones out of the 10 tokens or discs. And so the probability of getting not green or yellow is going to be 7 out of 10. Now this is independent probability, so the probabilities on the second branch down here are going to be the same. Doesn't matter what we do first time, it's still going to be the same probabilities of picking for the second one. Okay, so that's what my completed tree diagram should look like. Now part B says work out the probability that both discs are green. Okay, so both discs are green is going to be this branch I pick green, and then this branch I pick green. So then the probability of green is going to be multiplying every fraction along that route through the tree diagram. So I've got 1/5 here, look. So I'm going to multiply that, and I'm going to multiply that other one, 3/10. So 1/5 times 3/10. What's that going to give me? That's 3/50. Okay, so the probability of green is 3/50. Solve these simultaneous equations. I've got 7x plus 2y equals 100, and I've got 3x plus 2y is equal to 48. Now you actually know 3 methods for solving simultaneous equations for your GCSE exams, or you should know 3 methods. You've got solving by elimination, solving by substitution, and solving graphically. So no graphs here, so it's definitely not that one. So are we going to eliminate, or are we going to substitute here? Well, this one, when you've got 2 linear equations and they're all nicely lined up like this, the easiest way to solve them is by elimination. I'm going to get rid of one of the variables by adding or subtracting the 2 equations from each other. Okay, so here I'm seeing that I've got plus 2y and plus 2y there. So these are already the same. So it's going to be super easy to eliminate y, because all I need to do then is subtract one equation from the other. And if I take 2y and I take 2y away from it, I'm going to end up with no y's left. Okay? So doing the same with the other parts of the equation. 7x take away 3x leaves me with 4x. We've already said that 2y take away 2y is nothing. And then 100 take away 48, that leaves me with 52. So what's x then? Dividing both sides by 4, I'm going to get x is 52 over 4, which is 4 to the 52 go 13 times. So x is 13. Okay, so that wasn't pretty easy. Not quite done yet though, because we need to find the value of y as well. We need to find both x and y. Now we eliminated y earlier, but we had these two with equation 1, equation 2, and that was equation 1. Subtract equation 2. So now I'm going to substitute the value that we found x equals 13 into one of my equations. Now it doesn't really matter which one you sub it into. Whichever one has the easiest numbers is normally what I go for. So times them by 3 is marginally easier than times them by 7. So I'm going to pick equation 2 then, and then say, well, 3x, 3 lots of 13, plus 2y is equal to 48. So 3 13s, what's that, 39? So 39 plus 2y is 48. So then taking 39 away from both sides, that's going to give me 2y is equal to 9. And then dividing through by 2, I'm going to get y is 4.5. So therefore, the solution, x is 13, y is 4.5. Okay? Now, it's a good idea at this point to double check. You know, you don't want to wait until August when your exams come back to see if you were right or wrong. You've made a silly mistake. Just as a quick check on these ones, it's a good idea to substitute back into equation 1 and then see how you did. Make sure it all works. Okay? So if you used equation 1, sub into equation 2 to check it. If you used equation 2, sub into equation 1 to get to check it. So 7x, 7 lots of 13, is that plus 2 lots of 4.5, is that equal to 100? We're just going to double check. Well, 7 13s, what are 7 13s? 7 times 13, that comes to 91. So 91 plus 2 lots of 4.5 is 9. Is that equal to 100? Yes, it is. Kind of all good. Okay. Yeah. So we just, you know, just a visual check. So better to know in the test rather than when you get your results back if you made a silly mistake. So yeah, double check. Question 26. An open cardboard cylinder has radius of 1.9 centimeters and a height of 10.2 centimeters. Harry assumes that the net of the cylinder is a rectangle with a length L centimeters. Sorry, I was missing a bit of the question there. Work out the area of this rectangle. Okay. So it's a cardboard cylinder. I assume it's open, isn't it? Because, well, there may be more of the question. So what he's working out here is the curvy bit here, isn't it? Not the ends. So like the curvy bit here. Now the distance around here, the circumference of your circle, is going to be the same as that distance there, isn't it? Now, now the distance around the edge of the top of the circle there, the circumference of that circle is this edge along here, isn't it? Okay, and then this edge going down the side here is that one there. And we know that one's 10.2. So what is that one there then? That's just going to be the circumference of the circle. So do you know your formulas for circles? Cherry, pie, delicious, apple, pies are 2. We need the circumference for this one. It's c equals pi d. So then that length there is going to be pi times the diameter of the original circle. So if the radius is 1.9, we'd have to double it up to find the diameter. So it's 2 lots of 1.9. Okay, so 2 times 1.9. So 2 times 1.9, which comes to 3.8 pi. I'm just going to leave it in terms of pi for now. And then, so the area of the rectangle is going to be those two sides multiplied together, and it's going to be the 10.2 running down one side and the 3.8 pi running across the top. So I'm just going to times that together then. 10.2 times 3.8 times pi. That comes to 121 point, round it off to the nearest decimal place, 121.8. Okay, and I guess that's in square centimeters. It says, in fact, the net is a parallelogram, not a rectangle. What does this mean about the area of the net? Okay, well, You've probably seen this on tins, you know, made out of card. Sometimes it's like a strip running down like that, and that's what's happening here. So if you wrap this around, then it would still make that same cylinder shape, but you know, if you pull it apart, it will actually be a parallelogram rather than a rectangle. Now in terms of the area, it doesn't make any difference at all, is it? Because a parallelogram area is base times height, and my base is still the same. It's still the same circumference we had before, and the height is still the same. So what's going to change about the area? Nothing. It's exactly the same. It's still the area of the rectangle. It's still the same thing. Then part C says, what does this mean about the perimeter of the net? Well, the perimeter, what's happening with the perimeter? Well, the perimeter is going to change, isn't it? These two sides here are still the same as the rectangle we had, but these are definitely longer, aren't they? So the perimeter of this shape is going to be much longer than the perimeter of the original rectangle. So I'm going to say the perimeter is more than the perimeter of the rectangle, so it's that one there. AF, BC, DE and DF are straight lines. BC and DE are parallel. That's marked already, isn't it? So BC and DE being parallel, it's marked here. Look. It's always good to read the text though, because sometimes these things aren't added on. P is 3 times bigger than R. P is 3 times bigger than R. Work out the size of angle P. Okay, so we want to work out P, but the only thing I really know at the moment is this 72 down here. So rather than like hyper focusing on the thing that we've got to find, that P over there, I just think, well, what have I been given and what can I find? And then just kind of mosey around the diagram until I've got actually find what I want. Okay, so looking at that 72 there, I can see that, well, I know that this angle here is also 72 though, because these are vertically opposite. So that's also 72. And further, because these are parallel lines, then this angle over here is what we call a corresponding angle. So then that one is also 72 then, isn't it? So that's 72 too. Okay, now we've got an angle in the triangle containing P and R, and we know what the relationship between P and R is. So we know that P is 3 times bigger than R. So we could replace P with 3R then, couldn't we? If P is 3 times bigger than R, then P is equal to 3R. So rather than using P and R, I could just use 3R and R, and then we've just got one variable there. So I've got angles in the triangle that add up to 180. One of the angles is 72, one is R, and one is 3R. So I can say then that 3R plus R plus 72 must be equal to 180. Those three angles are adding up to 180. Okay, so collecting my like terms, that means 4R plus 72 is 180. And then taking 72 away from both sides, they're going to cancel, leaving me with 4R. And then 180 take away 72, that is 108. So that gives me a value of R by dividing both sides by 4. 108 divided by 4, 25 and 2, that's what, 27? So R is 27. Okay, now remember, R was not what we wanted to find. We wanted to find P. I found R, but I do know that P is equal to 3R. So I know that P is going to have to be 3 lots of 27 now then. So what's 3 lots of 27? 60 and 21, that's going to be 81, isn't it? So P is 81.
Mr. T, he's the best, helps you ace every test. Maths worries now.